And here we've got example problem 2-13. And I called this way 1 because I'm going to solve it the way I solved it. And then we're going to look at the way the book solved it. And then hopefully you can find a method that fits you. And also you can learn from the other method in case you ever have to use it. Because sometimes you get stuck in these little puzzles. And one of these other solutions is a way out of getting stuck. And that way you can solve the puzzle. So for this puzzle, we've got a 16 amp current source, 2 ohm resistor, 6 ohm resistor, 8 ohm resistor, 1 ohm resistor, 3 ohm resistor. And I left all the units off just for simplicity because usually when I solve these by hand, I try to simplify it down because I kind of know what we're talking about. But if it helps, look on the screen previous or the problem in the book and you can kind of see the exact units going through. So what is this problem asking for? This problem is asking for us to find IC, I'm going to call it. What is IC? So that's the current going through this 3 ohm resistor, which we know because it's the same current that's going to go through the one. So the same current is going around through these. And we're going to look. So conceptually, we have a 16 amp supply. This is going to go here, and the amperage is going to get broken up into part 1 and part 2. So this is a current divider at this point. Part of the current's going to go down here, and part of the current's going to go out here. And then when we have it going through here, we have another current divider. So then the little bit that came through here is going to get split up again. So this is a little more complicated, so we're going to try to simplify it out so we can get a nice clean solution. So the first thing we're going to do is a source transformation. So we're going to do our source here. We're going to do our... So remember, what the source transformation is saying is I can take this whole little part of the problem and rearrange it so that this resistor is in series with the voltage source if it's in parallel with the current source. So we have 2, and then we're going to continue on with our 6, and then that, and then we're going to continue on with our 1, continue on with our 3, and we're going to continue on with our 8. Okay, 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 okay. And this one is 6, 8, 1, and 3. Cool. So you see what we did? We just took this entire little bubble thing, this current and resistor in parallel, and we made this a voltage source and a resistor in series, and the rest of the problem stayed the same as up there. And so again, I'm just going to make the IC going through here because we know that's what we're looking for still. And then the other part that's important is, what is this new voltage source? What is the value of it? And we can do that really simply with V equals IR. We have the same 2 ohm resistor, so that's going to come down here. The current we knew was 16 previous to this, so 16 times 2 equals V, V equals 32 volts, so 32 over there. Cool, nice and easy way of solving that little puzzle. Now what do we do? Well, the next thing I did essentially simplify the problem out as much as I can. I did these two together because 6 plus 2 is going to be 8. That's easy. And I did these two together. 3 plus 1 equals 4. That's going to be easy as well. And again, it's going to stay the same current because it's the same loop. There's no branches coming off there, so we know that's going to be the same loop. So let's simplify this out a little more. 32 comes up. We've got our 8 ohm resistor. We've got another resistor coming down here, which is an 8 ohm resistor. And then we're going to pull these two together. Look at that. We're going to make a 4 ohm resistor right there. Because remember, 3 plus 1, 4. 8's the same, we haven't done anything. 6 plus 2, 8. So now we see that these two are in parallel and they're in series. Both of these are in series with 8. So we have to solve the parallel part first. So to solve the parallel part, we got 1 over 8 plus 1 over 4 to the reciprocal. And that's going to equal what? Well, type it into your calculator. We're going to get 8 over 3. 8 over 3 is the total resistance of these two. So we've simplified this out. I'm just going to draw it for now. 32. We got our resistor coming up here, which is our 8 ohm. And then we got another one coming down, which is our 8/3. So we've simplified both of these into this. So then what is this? The total resistance is 8 plus 8/3. 8 plus 8 over 3 equals what? That's going to equal 32 over 3. Cool. So this is our R total. R equivalent equals 32 over 3. And what that's saying is that all of these resistances added up properly are going to equal 32 over 3 ohms. So what we're going to do now is we're going to go back and redraw this circuit one more time. I'm going to copy, let's pick which one that we want to go. So we don't want to go so far back because I really like having that voltage source, so I'm going to keep this because current sources are a little weird to calculate things with. I could do it, but I'm just not as familiar. I like voltage source, that's my general standard way of doing it. This one, well, we know that this is going to be correct going through here, but we also know it's going to be the same current coming through here, that this is also IC. And we know that's IC because these are in series and they're added together. There's no branching. So this has to be the same current going through. So I like using this one because it's nice and simple. So let's draw this up. We've got a 32 volt source coming out. We've got an 8 ohm resistor coming down. We've got an 8 ohm resistor, and coming out here we've got a 4 ohm resistor. So the next piece that I'm going to ask about is how do we solve for this current going through here, this IC? And if you look, we know that we have this total equivalent resistance. So V equals IR. And that's going to tell us V equals IR. We have the total resistance, which is 32 over 3 for R. We don't know I, and we know the voltage is 32 volts. So 32 divided by 32 times 3, 3 equals I. So that's the total current coming out. So that's here. I equals 3 of this. That's what's coming out of this 32 volt source. It's not quite clear, but we'll go through again. So if we have 3 amps of current coming in here, what's happening? It's getting divided. How is it getting divided? How can we solve this? Well, one method of solving it is using the current divider rule. So we have I equals R over R1 plus R2 times I. So what this is saying, and that's not the same I, that's a different I. So this is going to be I total, and this one's going to be IC. So what this is saying is you pick which resistor, resistor 1 or resistor 2, and that is going to give you the current going through the other one. So if I pick the 8 ohm, I'm going to call this R1, that's R2, I'm going to pick that one. So if I pick what's going through this, that's going to solve for this current. So let me show you real fast. IC equals R1, so that's going to be 8 ohms over 8 plus 4, boom, and then times I total. So we have a 3 here. Remember, it's going to be 3 here as well. So 3 coming in equals 3 amps, and therefore IC equals 8 over 8, 9, 10, 11, 12 times 3, 2 amps. Boom. That's the answer. That is what IC is, and that's what the problem was asking. Now there's another cool kind of way to solve this if you're thinking about it. If you have 3 amps coming into this, and you know that 100% of it has to go to both of these, because remember, I equals I1 plus I2. If we look at this a little bit differently, you can see that of 3, 2 of it is going to go through this, and 1 is going to go through this, because this is twice the value of this. So remember, the power wants to go through the path of least resistance, so we're looking through this. So we can actually know that this is going to be 1 amp coming through, and this is going to be 2 amps, because 2 plus 1 amps equals 3. That's another way of just logically looking at it and kind of solving through. Can't always, I mean, you can always do that. It gets more complicated when you get other numbers that are not 2s and 1s. This method always works, current divider. So let me show you the way the book did it, which is quite a bit different than how I solved this. And again, I think there's something to learn though from that. So I'll be right back with 213 way 2.